Hi everybody, Thomas here from my channel Asteroid and welcome to another video. Today we are going to take a look to an asteroid called 2024 YR4 and we will use Universe Sandbox to simulate this asteroid. Why this particular asteroid? Well, maybe you have heard about it beginning of the year that there were it was like an observation in December of this particular asteroid, and it had a high probability of impacting the Earth with around 3.5%. Now, if you think, well, 3.5 is not that high, in astronomical terms, it is kind of high, but now it's almost zero, but there's still a chance that this asteroid will hit the moon. And instead of doing some complicated coding, I would suggest to use Universe Sandbox today. Just small disclaimer, I'm not being paid by Universe Sandbox. It's just one of the tools I would like to use for educational purposes. Now you see here a split screen. On the left hand side we have already some orbital elements of this asteroid from the NASA small body database, and on the right hand side we have Universe Sandbox, and the very first thing is we need to add the object. But the orbital elements here, they are valid for a certain date time, namely May 5th, 2025. Now, if we add the object now, here in the simulation is 2021, and we propagate it for a few years, then the elements change already to 2025, yeah, because of gravitational perturbations with Jupiter, Saturn, and also the other planets. So what we do, we have to go to now, or to the future, the 5th of May, and then add the object then. But first I would suggest to open a simulation that is a little bit less crowded. So we type in here solar in the search, and then we have the solar system, just the planets without any other objects but the planets. Very well. I would suggest to go now the advanced option menu, go here to 2025 May, and then also let's say midnight, and start the simulation. So we are now there where we can add our object. So we go to add, and then here the small icon where we have the minor planets, and then adding a random asteroid with this funny name, so you can change it later, but let's keep it like that. And we go now to motion, where we can then change the orbital elements a little bit further down, namely here. We have the semi-major axis here on the left side. You can always hover over the different letters, and it says here semi-major axis is A. So we have 5, 1, 5, 8, and so on. But the problem is in Universe Sandbox, it's always rounding to 2 digits. I think the semi-major axis 3 digits or so. So let's keep it like that. We freeze the semi-major axis, so when we change the eccentricity, the other value will stay the same. And the eccentricity is 0.662, and I think this one has 3 digits. Yep, perfect. The inclination is 3.41 degrees, if I'm not mistaken. And the argument of perihelion is 134.36. Here it's not considering any digits afterwards, and the longitude of ascending node is 271. Now, if you're wondering what all these values are, take a look in the playlist. I made another video about orbital elements, so you will understand what's going on. These 5 values, they define the shape and orientation of the orbit. What we need to do now is to place the object at the right position in time, space and time. And for this, we have something called the mean or true anomaly, just some angle values, let's say, that correspond to the time, namely the 5th of May 2025. And the value here is called M, mean anomaly, which is 40.40. So we can go here, change it to 40.40, and there we are, perfectly set for our simulation. So let's see, where is our... I lost it. I lost the object. That's bad. So if you it's like, I think there's like the option where you can show all the orbits regardless of their size, but we have here the option to click on it. Hey, where are you? There you are. So there is the object, Pomnast. Let's keep it by its name, and it's still disappearing. I should change the settings, but anyway, we have here now our orbit, and now we can propagate it to the future. But let's first have a look whether this is correct what we have. So this is the orientation. The ellipse goes a little bit to the down. Here's Earth, Mars close to the asteroid, because here in the small body database we can scroll up and have our easy understandable orbit viewer, and it seems that this corresponds to what we see here on the right hand side. Perfect. So what we can do now is we simulate now everything to the future, namely the date where the asteroid was assumed to hit Earth. And this is 2032, and it's actually around Christmas. I think it was the 22nd, so I would suggest to go to the 20th. Press enter and let's start the simulation. And there we are. So let's go closer and closer, and also a little bit, just making it a little bit smaller. And there we are. There is Earth and there is our small asteroid. Now, this is not exactly the 22nd. If I now go a little bit in the future, yeah, you'll see that a few days later the distance is bigger, because the orbital elements change, of course. And of course, you have to consider that we were not able to give all the precise orbital elements plus the uncertainties. So I would suggest that we are going back in time. And we see that, yeah, this is like the distance. It's not really hitting the planet Earth, really. So this is... So if we click on the asteroid, hold shift and click on Earth, we see now here the distance. It's like around 0.1 astronomical units. So it's not that close, I would say. And it's also the distance is way larger than currently anticipated, with around 300,000 kilometers. So one astronomical unit is 150 million kilometers. So this is around 15 million kilometers. And this is way more than the current simulation that suggests that it's hitting the moon. Why? There are different reasons. First of all, of course, on the left-hand side, we were not able to add all the parameters with their uncertainty. That's the very first thing, also with their precision. And the second thing is that we also do, so let's say the I don't know the exact implementation of Universe Sandbox. It's possible that NASA or whoever, or ESA, is having more, let's say, detailed and sophisticated n-body simulations, which are way more precise than Universe Sandbox. Although Universe Sandbox is super great, don't get me wrong, but it's not perfect for highly scientific accurate measurements. It doesn't matter, because at least you get the gist of the situation between this asteroid 2024 YR4 and our home planet. I hope you learned something. Go into the small body database, look for other objects, try to simulate them in Universe Sandbox and see how they behave. There are like 10,000s of near-Earth objects already in the database. So take a look at it, and I hope you enjoyed the video, and see you next time.